Assalamu alaikum and good evening, everybody, and welcome to the BEAWorld Student Webinar Session number 12. I, Numaira Iram, am honored to moderate today's session. I'll start by sincerely thanking the organizer, presenter, chief guest, and participants for making this webinar successful. Today's topic of discussion will be nuclear energy, importance, sustainability, and smart technologies. The discussion will last for 40 minutes, and we will have a question and answer session afterwards for 20 minutes. Let me introduce our speaker, Ragib Nihal Sadab, a student in his third year of computer engineering at Khalifa University, Abu Dhabi, UAE. He completed his O-level and APU examinations with distinction at the International School of Shefat, an achievement that earned him the Golden Visa and a 100% scholarship from Khalifa University. As a part of his continuous effort to build technical expertise, Ragib completed a 7-day intensive AI and cyber winter school, gaining foundational competencies in these fields. He further enhanced his skills by participating in a day-long workshop, Introduction to Quantum Computing, organized by Khalifa University. Throughout his university studies, Ragib has been recognized multiple times on the president's list for his academic performance and has received several awards from various competitions. He has also published several articles in BEAWorld's magazine, Synergy, including on the role of nuclear energy in achieving a sustainable future, reflecting his interest in clean energy and technological innovation. In addition, Ragib has also conducted several webinar sessions and participated in public speaking through BEAWorld webinar program, earning recognition as the best speaker on multiple occasions. Now I will introduce our chief guest of today's session, Dr. Habibul Khondker, a professor of social sciences at Zayed University, Abu Dhabi, UAE. I'm confident that today's webinar session will be both enjoyable and incredibly informative for our career development. Now I request Ragib Nihal Sadab to take the floor and begin the presentation.
Thank you very much. So as she said, my name is Ragib. I'm a computer engineering student. And this presentation has nothing to do with my major, actually. This came completely out of self-interest and also some courses I took in university. So I'm pretty new to this topic, and I just wanted to share some balanced insights regarding what's happening currently with nuclear energy. So the topic is nuclear energy, its importance, its role in sustainability, and the smart technologies associated with it. So let's begin. The first part, I'll be talking about the energy and the climate challenge. So climate change is a huge issue, and we need to act quick. Greenhouse gas emissions from energy use is affecting climate change, and the main reason is due to fossil fuels. And so countries have gathered to achieve net zero by the year 2050 in order to prevent any adverse changes in the coming future. Now, one of the biggest problems now with the energy system is that 80% of global energy comes from fossil fuels. That includes coal, natural gas, stuff like that. And this needs to be changed. One proposal is electrification, and that is to electrify all the sectors that can be electrified. And an example of that is your petrol car. Petrol cars can be transitioned into electric vehicles, and that is being done at a very rapid rate currently. Same with gas heating and even fossil fuel industrial processes. But the problem still remains. Sorry? The problem still remains. Even though we're transitioning to electrification, the majority of electricity is still being powered by fossil fuel plants. And you can see it in this graph. This is showing the percentages of global electricity generation by the source. And you can see fossil fuels are dominating, with 60% of them contributing to the electricity around the world. Now, there are renewables that also contribute to electricity. That's one of the main reasons why we should move to electricity. But renewables, although they constitute 30%, renewables, of course, have some problems, just like every other source of energy. Some of the main problems is that they are not intermittency issues. For example, they do not operate throughout the entire year at all times. One of the main examples is solar power. Solar power can't run without the sun. Same with wind. If there's no wind, wind power becomes zero. And with that comes additional storage and battery and such facilities that even add to this problem. Now, if you look at the chart, there is one key player that is not under the renewables category, and that is nuclear energy, which contributes to 9% of global electricity demand. Now, nuclear is a non-renewable resource, but it is sustainable, and we will get into what makes it so good and special. So let's start with a brief history of nuclear power to understand. And this starts in the year 1896, where scientists discovered a very peculiar kind of rock or element. And this type of element was emitting heat by itself. Now, the term we give that is called radioactivity. And that is because the rocks themselves are very unstable, which causes such heat to come out. Now, over the years, people have been doing research on radioactive elements and also on the subatomic scales and even atomic scales. They discovered the nucleus and made a model based on it. And in the next few years, a very important process was discovered known as nuclear fission. And what nuclear fission basically is, it's the breaking of atoms, which releases a lot of energy in very simple terms. And this led to the first controlled chain reaction, which is rapid successions of nuclear fission reactions, basically. Continuing on to the history, World War II comes in, and this is where nuclear plays its first role. Before nuclear power plants were even a thing, the Manhattan Project gave rise to nuclear weapons. Nuclear weapons came first, and many places were bombed, huge areas of places. However, it was only after the war that people started to go towards a more peaceful side. And that's when nuclear power plants, that idea came. And there were several policies to reduce the amount of nuclear weapons that were produced. And many countries saw potential in nuclear energy, such as the US, UK, Soviet Union back then, France, Canada, later Japan, and these countries. And this was the peak time for nuclear energy percentage-wise, because it constituted to 17% of global electricity at that time. And Soviet Union was the first to adopt such a power plant. Now, let's look at how nuclear power actually produces electricity. And it's actually not that different from how other sources do the same thing. The main pipeline is here. You have an energy source or a fuel, turbine to rotate a generator, and that makes electricity. That's a very simple blueprint. Now, how does fossil fuel power plant does that? They do it by using the fuel source as either coal or gas. The coal or gas is burned, it produces heat. The heat is used to heat water, creates steam, and generates electricity. Geothermal also operates with water. The earth heats the water, produces steam, and that generates electricity through turning a turbine. Hydropower uses the water directly to spin a turbine. Wind moves air directly, turns a rotor connected to a generator. Now, how does nuclear work? Very simple, just like the only difference is the energy source. It's very similar to fossil fuel plant. The energy source in this case would be a radioactive material, and nuclear fission is used to produce heat. Now, this is the main fuel of a nuclear power plant or a nuclear reactor, uranium. Uranium is naturally occurring, and it's most commonly found in the form of U-238. But a very small percentage of this uranium is radioactive. And this part is what's used in nuclear fission in most power plants. And there's a process called enrichment, which basically increases the concentration of that radioactive substance to maximize how much energy you can get. So here's how nuclear fission actually works. So I'll try to draw it. So first step is a neutron strikes a U-235 nucleus. So if you have a neutron, you shoot it at very high speeds, and it collides with a U-238 or 235 nucleus. After that, this causes it to break into two smaller particles. And this releases a huge amount of energy and also some other tiny neutrons. This is basically nuclear fission. But there's not just one uranium, there's multiple. And these neutrons also collide with other uranium. And these break into even smaller bits. And this is called a chain reaction. All of this produces huge amounts of energy. As you can see in this image, it's being blocked by the drawing, but you can see how much energy it can draw through these chain reactions. And this is basically the pipeline: fission, heat, the water takes the heat, steam is created, turbine, generator, and then electricity. Now, why even consider nuclear energy if it performs basically the same as all the other ones, other sources of electricity? One of the main reasons is the low life cycle emissions, or low greenhouse gas emissions. Now, everyone has probably seen these. That's probably what first comes to mind to many people when they think of nuclear power plants. But to people's surprise, this is not actually a nuclear reactor. This is a cooling tower meant to cool the reactor. And what you see over here is not smoke. This is just water vapor. So there's no carbon dioxide being released or emitted. This is a nuclear reactor containment building. So the nuclear reactor is actually inside this building. And you can't see it from outside. And this containment building is built so that to be safe, to keep the reactor inside without letting anything go outside, because that would be very dangerous. And this is what's inside this is basically a nuclear reactor inside the dome. Now, cooling towers are not unique to nuclear power plants. They're also used at coal-fired power plants, natural gas, steel mills, and some large industrial facilities. Their job is simply to remove excess heat from the plant. Why are they needed? You see, the nuclear reactor generates a lot of heat through fission, as I showed. That heat is used to boil water into steam, which generates electricity. Now, the steam that's passed through the turbine, it needs to be cooled back into liquid so it can be reused. That's where the cooling system comes in. Now, back to the main reason. Nuclear fission itself does not directly emit any greenhouse gases. Most emissions actually come from construction, mining, fuel processing, and stuff like that, which are not related to the essence of nuclear energy. Nuclear gas plants emit around 40 times, natural gas plants emit around 40 times more CO2 than nuclear power plants. Nuclear energy is considered one of the cleanest and most sustainable sources of electricity because of this. And countries with significant nuclear power, such as Canada, France, South Korea, have achieved rapid reductions in electricity sector because of nuclear energy's low carbon emissions. Now, let's look at the second point, why nuclear energy is considered important, and that is efficiency. Now, what you see in this image, these are actually uranium pellets. It's about the length of your tip of your finger, from the tip of your finger to your first joint of your index finger. And one uranium pellet amounts to the same energy that 1,000 kilograms of coal can give. Now, this makes uranium incredibly dense, one of the densest forms of energy ever. And high energy density reduces the need for frequent fuel deliveries and refueling. And this makes nuclear power very beneficial, especially for countries with limited fuel resources. Even though it's non-renewable, this density helps nuclear's case. Now, the third point is reliability and firm energy generation. How much electricity every plant produces is shown here. You see, nuclear has very high reliability. It operates 92% of the time, almost all throughout the year. It provides continuous, uninterrupted electricity. Uh, it's more consistent than the other renewables, such as solar and wind, because they rely on environmental factors, unlike nuclear energy. And this makes nuclear the most reliable. Now, there are many challenges to nuclear energy, of course, and many public concerns. One of the main is accidents and what could go wrong in nuclear facilities. Now, there are many famous ones. The first of its kind is the 3 Mile Island in 1979. And this was caused due to a malfunction in the nuclear power plant, some design problems and confusion, and partial core meltdown. Meltdown happens when the core of the reactor becomes extremely hot and the cooling process is not able to cool it down. And this does not lead to an explosion, but it can release huge amounts of radiation, which can be harmful for people's bodies. But in the first incident, no deaths occurred due to the radiation exactly, because all the radiation was contained. However, Chernobyl was one of the biggest disasters from nuclear power plants. It happened in Ukraine, and a lot of people are shying away from nuclear because of this huge incident, which caused huge amounts of radiation into the air, and it even led to the area of Chernobyl being excluded. That means no people could enter for a very long time. Another one is Fukushima in Japan. This was caused by natural disasters, and it also caused Germany to close down their facilities due to public demand and stuff like that. Now, could these accidents happen again? Actually, most of those accidents, the main reason why they happened is because of negligence. Proper guidelines were not followed to perfection, and those incidents could have been easily prevented if they were more strict and also more smart with where they placed their power plants, such as staying away from areas that are prone to natural disasters, such as tsunamis and stuff like that. And many lessons were learned from this. And with the guidelines that are taking place now, it is, I wouldn't say impossible, but almost impossible for anything of that scale to happen. And even if it does happen, there are implementations that could prevent that. Now, how safe is nuclear compared to other sources? From this graph, it shows the number of deaths per terawatt hour of energy produced, with coal having 25 deaths and nuclear having less than 1. This makes nuclear actually one of the safest major energy sources per unit electricity produced, despite all the Chernobyl incidents and stuff being accounted for. And studies even argue that nuclear even saved lives. And people think nuclear is dangerous, but it actually is not as dangerous as they think. It's like the car versus plane example. Plane accidents are much less likely than car accidents, but because plane accidents cause such huge scenes, they tend to stick to people's minds more. In fact, coal actually results in more death of people through pollution than nuclear ever did. Nuclear waste is another concern. What is nuclear waste? It's basically when the fuel of the nuclear reactor, the uranium, becomes used for many years and becomes less efficient for sustaining even more nuclear reactions. The used fuel is called spent nuclear fuel or nuclear waste. And what's the problem with nuclear waste? It's highly radioactive, it generates heat, and it requires careful handling, and it can last up to thousands of years. However, there are many safety and storage methods, such as spent fuel pool, which basically helps with cooling the waste. Dry cask storage. Now, these storage facilities look like this. They can be stored outside, and they are very well protected. It can survive earthquakes, fires, floods, even missiles. And it's not like the cartoonish tanks you see here. It's nothing like that. The third is geological disposal, and this is the permanent solution to disposing of nuclear waste. And Finland, the Onkalo repository, actually is the first to implement such permanent geological disposals. And this makes storage very safe. Now, we often fear the waste we can see being stored, like the nuclear waste, yet we rarely question the waste we can't see being released into the air every day. Nuclear waste is safely deposited, but people are still afraid. Even the coal power plants literally emit their waste openly into the air, causing millions of deaths worldwide. Now, one of the most serious concerns is nuclear proliferation. Uh, and that is due to plutonium, which can actually be used to create nuclear weapons. But although this is a valid concern, it is actually very difficult to produce nuclear weapons. And to prevent that from even happening, there are very strict guidelines from very well-known organizations, such as the International Atomic Energy Association, that carefully regulate countries' facilities so that these don't happen. Now, the biggest problem is probably cost. And nuclear power plants can be very expensive because of their complex engineering, high safety and quality standards so that incidents don't take place, long licensing and construction periods. And the time is one of the main factors as well. Some plants can take up to 10 years. Some can be taken up to 4 years to build, depending on country policies. And cost compared to what exactly? Fossil fuels are obviously the cheapest, but compared to renewables like solar and wind, nuclear is not really that expensive. When you account for capacities of both nuclear can run all around the world, all throughout the year, I mean, but renewables can't. More money needs to be spent on energy storages, facilities, and batteries to make renewables more reliable, which add to their cost. And what measures are being taken to actually help nuclear plants cost less? Since I mentioned that plants operate using the same idea of heating water to turn turbines, perhaps nuclear plants can save money by replacing other plants. Coal plants already have similar facilities. They can be replaced with nuclear plants to save money because the cooling facilities and stuff are already in place. Nuclear might have a high upfront cost, but in the long run, it gets cheaper as it scales and is also better for the environment. And a safe environment is just priceless. Now let's look at the global leaders. 3 countries to mention briefly. Number 1 is France. And France is one of the best examples of nuclear power plant practices because 67% of the country's electricity comes from nuclear. So it is basically a nuclear country when it comes to energy. United States is the largest producer and is well known for innovation. China is the fastest growing one as well, and they also are working on very different technologies such as fusion research and fast reactors. Now, I did mention that back the peak of nuclear percentage-wise was 17% back in the day. Nowadays, it's around 9%. And that is because of the global concerns, but slowly people are starting to look more forward into nuclear energy. Now let's focus on the UAE exactly. The UAE has a nuclear energy plant called the Baraka Nuclear Energy Plant. And this is located in Al Dhafra region in Abu Dhabi. And the first thing you probably notice is that there are no huge towers. You can probably just see 4 dome-shaped structures. That's because this plant uses seawater for cooling instead of the dedicated big cooling towers. Now, these 4 units uh, are called they're, of course, they hold the nuclear reactors, but they're the containment facilities for the nuclear reactors, and there are only four, and they produce up to 40 terawatt hour electricity every year, and this powers, only these four reactors power 25% of UAE's electricity demand. Now, let's take a look at some smart nuclear technologies and some future ones. So these are small modular reactors, SMRs, basically tiny nuclear reactors. Now, what are they exactly? They're very tiny, and they basically just supply 10 to 300 megawatts of electricity, and they're modules that can be transported to site and assembled, unlike the large scale ones that are developed on the site without being transported. Now, the key technologies, they have passive cooling systems, they have integrated reactor design, such as the steaming, the reactor core, and all that stuff is all in the same vessel. And they also have support for underground installation. As for the costs, it is hard to say for now, but economies of scale from mass production could eventually reduce the costs of SMRs. But this has not been demonstrated yet commercially. And why are they needed? First of all, they have shorter build times. They are very flexible when it comes to deployment, especially for regions where large reactors are impractical, and they're scalable. They're built in modules and can be added as electricity demand grows. SMRs are considered most promising for remote communities, military bases, mining sites, and industrial facilities where reliable power is more valuable than the lowest electricity price. Another very interesting technology is called digital twin technology. What is it? It's a real-time virtual replica of a physical nuclear power plant or its components. So it's basically a virtual replication of the nuclear power plant you see from the inside out. It is continuously updated using live data from plant sensors and monitoring systems. And key technologies that this technology has, they have IoT sensors to collect real-time data on temperature, pressure, vibration, flow, and radiation. They have simulation models to replicate plant behavior under different conditions, and also potential to integrate AI and machine learning to analyze data, predict failures, and optimize maintenance schedules. And another one is augmented reality and virtual reality. And actually, all these technologies, the UAE and all the other countries are looking forward to them. What exactly are these two? Augmented reality and virtual are pretty similar. Augmented, however, as you can see on the picture on the left, it overlays the digital information onto the real world itself. And it can be viewed using smart glasses or tablets. So it's basically enhancing the real world through a screen and gives you more details on everything. Virtual reality, however, is not integrated into the real world. It's a completely immersive digital environment for training and simulation. Now, what's an example use case of AR? One is, let's take a look at assistant maintenance, for example. Let's say a technician wearing AR smart glasses is assigned to inspect a reactor cooling valve. As they look at the equipment, the headset can display the valve's ID, the operating status, similar to what you see in the left picture, real-time temperature and pressure readings in front of them, step-by-step maintenance instructions, and safety warnings and required tools. As for virtual reality, it allows users to simulate critical scenarios. Example would be emergency operator training. Let's say new reactor operators, they use a VR simulator that recreates nuclear power plant's control room. They practice responding to scenarios such as coolant pump failure, loss of power, emergency reactor shutdown. The simulation can allow operators to make decisions and observe the plant response without any risk to the real facility. Now, let me see if I missed anything. Uh, to add on to the digital twin technology, uh, I guess an example, I forgot to give an example. An example would be an emergency scenario simulation, like the previous slide. Before implementing a new operating procedure, engineers can test it on the plant's digital twin. They simulate events such as sudden loss of coolant flow or an equipment malfunction to evaluate the plant's response without affecting the actual reactor. And this could also lead to further technologies such as autonomous nuclear power plants. Nuclear power plants that are run entirely by themselves, of course, with human intervention, and also autonomous inspection robots in areas such as that are could be dangerous for humans to go into or hard, such as snake-like robots that inspect very narrow, thin pipes, self-climbing robots for containment walls, and radiation-resistant robotic devices as well. Now, I would like to end it off by saying the choice is not necessarily nuclear or renewables. You don't have to pick one or the other. They're not competitors. As long as fossil fuels dominate, the useful question is how nuclear and renewables can work together safely, economically, and responsibly to displace coal, oil, and gas. And that's all. Thank you.
Thank you, Ragib Nihal, for that excellent presentation. You truly are an inspiration to all of us. Now we will open the floor for questions. If anyone has a question for our speaker, please raise your hand or you may post your question in the chat box. I see that Mr. SM Atar Rahman has raised his hand. You may ask a question.
Thank you, Mr. Ragib, for your nice presentation. সুন্দর উপস্থাপনা। কারণ একটা জিনিস হলো আপনি কি মনে করেন যে বাংলাদেশের জন্য এই নিউক্লিয়ার এনার্জিতে অপারেট করা এবং এটা ফিজিবল কিনা একটা জিনিস, আর একটা হলো বাংলাদেশে কি এসএমআরটা করা ভালো না নর্মাল নিউক্লিয়ার এনার্জিটা ব্যবহার করা ভালো? থ্যাংক ইউ।
Okay, so the question was whether nuclear facilities are feasible in Bangladesh and whether large-scale ones are better or smaller-scale ones. So for the first question, I actually haven't looked into Bangladesh's conditions, so this is just my guess from now. I would say Bangladesh might not be able to build such systems. Nuclear might not be the best, especially for the short term, because it's a huge investment. Starting a nuclear power plant has insane, like very high upfront costs, up to billions, maybe up to even 10 billion amount in USD. So this can be very difficult. As for whether small reactors are feasible or not, that's also tougher to say because, as I said in the slides, they have not been commercially tested. So they can, we're not sure if small reactors can be scaled up and be made less expensive in the long run. So that is also something that the country would have to look into. And if it does, there are benefits of using nuclear even in Bangladesh, because as I said, nuclear is good for countries that struggle with fuel resource. And because of uranium's very dense energy composition, it can be useful in the long run for Bangladesh. So it all depends.
Hello. Hello.
Hello.
Yes.
Yes.
You may ask your question.
আমি যেটা বলতে চাচ্ছি সেটা হলো বাংলাদেশের মতো দেশে নিউক্লিয়ার পাওয়ার প্ল্যান্ট মাধ্যমে ইলেকট্রিসিটি উৎপাদন করা আসলেই মানে এটা দরকার। কিন্তু আমার প্রশ্ন হলো যে এটা তো অনেক কস্টলি, তারপর হলো যে কস্টলি এবং এটা আমার মনে হয় আরো মানে মানে দীর্ঘমেয়াদে এটা হলো বাস্তবায়ন হলে আমাদের দেশের অর্থনীতির জন্য ভালো হবে। তবে এই মুহূর্তে যদি আমরা করতে পারতাম, এবং সেটা আমার মনে হয় না যে এটা করা সম্ভব, কারণ হলো যে এমনি তো পপুলাস কান্ট্রি আমাদের দেশ, এবং এখানে একটা নিউক্লিয়ার পাওয়ার প্ল্যান্ট পরিচালনা করার মতো সেরকম এক্সপার্টিস, সেরকম টেকনোলজি বা সেরকমের ম্যান পাওয়ার এখনো গড়ে ওঠে নাই। তো সেই 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 দিক থেকে আমি বলবো যে এরকম পাওয়ার প্ল্যান্ট এই মুহূর্তে বা হয়তো প্রতি 5 বছর পর পর বা অসংখ্য বা বেশ কিছু সংখ্যক পাওয়ার প্ল্যান্ট, যেমনটি আপনি উদাহরণ দিলেন ফ্রান্স, নিউক্লিয়ার কান্ট্রি, আমরা হয়তো ওই পর্যায়ে যেতে পারবো না এবং এটা সম্ভবও না। তবে যেটুকু আপনার প্রেজেন্টেশনে বুঝলাম যে হলো যে নিঃসন্দেহে এই নিউক্লিয়ার পাওয়ার প্ল্যান্ট ইট ইজ দ্য বেস্ট সলিউশন ফর ইলেকট্রিসিটি সাপ্লাই ইন বাংলাদেশ। এটা সম্ভব, এটা এর ভালো, এটা আমরা গ্রহণ করতে পারি, কিন্তু আমার মনে হয় যে আমরা খুব শর্টলি হয়তো আগামী 10-20 বছরে 10-20 বছরে হয়তো হয়তো আরেকটা হতে পারে, আরেকটা যেমন রূপপুর একটা হয়ে গেছে, হয়তো আরেকটাতে যাব, তবে স্লোলি যেতে হবে আমাদের, আমার কাছে মনে হয়। আপনি কি মনে করেন?
Yeah, definitely. Another concern is maybe public sentiment. If there's many nuclear plants being taken place, maybe the public will also be against it. That's also one of the reasons why some countries like Germany, they didn't expand their nuclear facilities. In fact, they shut down their facilities as well. Another thing is Bangladesh is prone to some natural disasters, mainly flooding. So that will also have to be taken into account. Heavy rain and stuff like that. They would need to have very safe environments for that. But I think as technology advances and as public sentiment improves, the public view improves towards a more nuclear side, I think technologies like the small reactors, they can definitely help countries like Bangladesh, because even just a few nuclear reactors can make a huge difference. As you saw in the UAE, just 4 nuclear reactors accounted for 25% of their electricity. So I think it's definitely possible in the future.
Okay, thank you very much.
I see that Miss Nushat Madihat has raised her hand. You may ask your question.
My question is, what are the career opportunities for engineers from other disciplines in the nuclear industry, specifically people who didn't study nuclear engineering?
I think that would be maybe related to the last few technologies I mentioned in the slides. I would say the digital twin technology, it might not need as much nuclear knowledge, like principles of nuclear energy, as the other technologies I mentioned, because digital twins are basically just simulations or replicas using a bunch of sensors and stuff like that, as well as the robots that can, tiny robots that can creak into small pipes to look for damages and stuff like that, where humans would not be expected to directly go and experience, because it would be dangerous. And also, yeah, those types of stuff don't really require nuclear knowledge. Also, augmented reality, definitely not. It's all based on computing principles. Also, if you're looking into, I'm not sure if your question was directed mostly towards computer, but those are mostly computer. If you're talking about maybe civil or stuff like that, actually, the containment facilities, there's a lot of improvement that can be made. Nuclear reactors, they have a lifespan of about 60 to 80 years. And it's not like they will explode at the end. It's just that because of how much energy is being generated inside a nuclear reactor, the walls of the facility, of the building, actually can get weakened and stuff like that. And so civil engineers and industrial engineers can definitely contribute to that as well. And also there's emerging technologies such as nuclear fusion, which requires even more advanced buildings to even grasp such, technologies. Because nuclear fission is basically the same principle as how stars function. And so many leaps need to be made in that.
I believe Mr. Asimata Rahman has another question.
Yeah,
You may ask.
থ্যাংক ইউ মিস্টার রাজীব। আমার জানতে ইচ্ছা করতেছে, বাংলা বললে অসুবিধা আছে রাজীব?
I prefer English, but
Okay, thank you. You mentioned that 9% worldwide nuclear energy is now used. All the advanced countries, they have the capacity in technological and financial, everything. Yet only it cannot go to 2 digits. In our country, like technologically behind, financially behind, and human psychology in Bangladeshi people is that nuclear energy is a very dangerous thing. It can happen, damage anything. And technically, it has waste disposal of nuclear, and Bangladesh is a very much earthquake intensity has. So on the ground, location for the nuclear energy station is very important one. And another thing is where you will do it or execute it or implement it, and how the foreign donors or expertise will train our people to cope up with any accident if occurred. That's my question and opinion.
So just to rephrase at the end, your question was how nuclear waste disposal can be taken place in Bangladesh, which has a lot of earthquakes, and how incidents can be countered if happened, right?
ঠিক আছে, okay.
Okay, so yeah, that's actually a very good concern, and that's maybe one of the things that can prevent Bangladesh from having such nuclear facilities. But this is just from my guess, because the Fukushima, Japan incident, earthquakes and tsunamis were the reason why such incidents took place. However, now with nuclear waste and stuff like that, the technology and the infrastructure that actually protects those waste and those systems is much more advanced. Some of them can even withstand earthquakes and even missiles, and those are the ones that are above ground. But I'm not sure exactly how they would fare in the Bangladesh landscape, especially the underground facilities. That I'll have to look into it. I'm not sure. But in the case that such stuff happens, there are buildings that could be put into place that can prevent the radioactive material from escaping into the environment. But I haven't looked into it too much, so I can't give you a clear answer.
Thank you.
We'll take our last question of the session from Mr. Abdullah Tafim. You may ask a question.
First of all, beautiful presentation. And secondly, I had a question. How much do you think the field of nuclear engineering is going to change, let's say 10 years from now, from what we know right now? Is it going to be like a whole different field, or like there will be minor advancements to what we already know?
I think from the technologies that are emerging, I think we can see very rapid developments in few years. In the next 10 years, I'd say a lot of development would take place in, for example, the technologies like uh, the small reactors and stuff like that. And depending on what discoveries happen, for example, uranium is like the main fuel source right now. And people are discovering newer elements to use as fuel, such as thorium and stuff like that. So there's a lot of research taking place, and I think it's continuously growing, and it depends on public sentiment as well. And it's not just nuclear, even like other disciplines, they're figuring out how to, use those new fuel sources to generate electricity. Because those fuel sources could be even safer than uranium in terms of waste disposal and stuff like that. And also nuclear fusion, depending on how well that goes, I think nuclear has a lot of potential in the upcoming future. Because as of now, nuclear fusion is, they have made two giant leaps. Nuclear fusion was discovered around 100 years ago. And recently, they figured out how to generate more energy from fusion than what is spent. So those are two huge leaps. But in that regard, actually, I can't tell if there's probably not going to be huge leaps in that regard in the next 10 years, nuclear fusion specifically, because the only problem we have now is how to get the electricity from that energy. Because fusion is basically how stars function. And the buildings you need to contain a star, you could imagine how, advanced that would be. So I guess, in a sense, in the next 10 years, research-wise, there's going to be a lot of potential. But career-wise, I'd say it's still looking good, but I'm not sure. I don't have the relevant knowledge to comment too much about that. But I think in the next 10, 20, 50, even 100 years, with the global goals such as net zero carbon by 2050, I think nuclear is going to play one of the biggest roles in that in achieving that goal. And I think that's also one of the main reasons why nuclear will continue to grow as a field.
Thank you.
Thank you to our presenter for the presentation. And with that, we end our question and answer session. Thank you all for your active engagement. Now I will invite Engineer Ahmed Hossein Chaudhary to share a few words on today's session.
Hello all, Assalamu alaikum. First of all, let me introduce myself. I feel comfortable to talk in Bengali, but at Ragib prefer, so I'll go for English. First, let me introduce myself. My name is Ahmed Hossein Chaudhary. I work for Taka Transmission, Abu Dhabi, and before I was PDB employee, I work in Kapta Hydroelectric Power Station for 4 years. Then I came here in the Middle East, and from 1993, I'm with this company, Taka Transmission. I graduated from Kuwait in 1986 in electrical engineering. Thanks, Ragib, for your beautiful presentation of nuclear energy. And though it is out of your field from the computer engineering, you did very well, and your presentation style, everything is very good, is above the marks. Thank Numaira. We know actually you people are very talented student. We know that who qualify to study in Khalifa University. We know the level of merit of those students. So thanks, Ragib, for this presentation. And Numaira, you know that actually a few days back or last month, maybe we saw the few medals, I think 8 or 9 medals in your necks hanging. So we know this. You also has some publications and all these things. So really, we are very proud of our future generation here in the Middle East. Thank you again. Let me come to these nuclear and energies and the Baraka power stations. See, I am working in the power sector, power transmission, and we are very close to the generation of my company. Baraka, from the Baraka when it started, actually they are talking about the Baraka in year before 2000. Actually, they made many presentation here in Abu Dhabi Exhibition Center. Even I have some nuclear fuel.
Numaira.
I have with me actually. I got presentation from the Baraka nuclear people,
Numaira.
and they made many presentation with us in our company. And you are hearing me, everybody?
Yes.
Okay. And why they made actually Baraka power plant about 150 kilometer away from the Abu Dhabi city? That is the reason, due to considering this the risk involved for this type of the nuclear. It should be the away from the where this public concentration are there. So that's why they made they selected 3 places. Finally, they made it in the Baraka. It has 6 gigawatt, each 4 units, each unit 1.5 gigawatt, that is 15,000 megawatt. Whereas in Bangladesh, in Rupur, it is 2.4 gigawatt, I think, what I know. The renewable energy always, especially the nuclear, renewable energy always coming, it is all not green there actually. It is coming with some consequences. See, I work in the Kaptai power station. This is also hydroelectric, the renewable energy. It is having the full capacity only 230 megawatt, that is 0.23 gigawatt, comparing to the 6 gigawatt in Baraka, 2.23. But for the Kaptai power station, they made a huge town there in the hill, in the jungle, and they submerged whole area, big area, the above Rangamati for the dam, for the water. So is really having huge environmental consequence. Anyway, we know the Fukushima example. What happened there? Still, there Japan is still suffering for this. I want to touch another point. Someone asked about the for the other engineer, electrical engineer, civil engineer, to work in the nuclear. See, when we are talking about the nuclear power plant, that is we are talking about the reactor part only. Whereas in where there's the gas turbine and all the turbine part, there's the mechanical part, there's the nuclear part, then whole generation part aside. So for the generation, it is electricity, it is electrical. So the Baraka, 60 to 70% engineers are working on electrical engineer. The nuclear engineer and all, they are working for the reactor side only, for the reactor. For the generation, there is all electrical engineer, and coming with the civil, mechanical, and all type of engineer are there. I don't want to. I think I just what I tried to talk. Actually, I spoke everything. I don't want to take much time, and thank you everybody to listening me. Thanks, Ragib, again. You people and Numaira, you people feel us proud actually. Thank you very much. Thank you, everybody.
Thank you to Engineer Ahmed Hossein Chaudhary for your wonderful speech. Now I will invite Mr. Manzoor Khan to share a few words on today's session.
Assalamu alaikum. I'm sorry to interrupting. My name is Mohammad Afzal. I'm sorry that I could not touch the time on time. I'm in the car, so that I believe that I'll get 2 minutes to talk.
Yes, you may begin.
I can start now.
Yes, absolutely.
Okay. You know, same sector with Ahmed Bhai. I'm working in this country for 32 years, in Dubai Electricity for 6 years, and now 26 plus years in Abu Dhabi sector, power sector. It's you can say before it was Transco, now it is called Taka Transmission. Myself and Ahmed Chaudhary Bhai working the same company, you can say. I started the work as a control engineer, Dubai Electricity Control, and as well as Transco Control Center, Central Control Center, still now. Now Abu Dhabi having 2 control center, and the function of the control center, as you know, for every country there is a control center, and it is the controlling whole network, whole system, starting from say line connection, commissioning of power plant like a conventional nuclear power plant, as well as transmission line, substations, all these things, and outage management plan, system security, and voltage control, frequency control, everything is controlled by our control room. So since I think our youngster, I think his name is Ragib. I'm sorry that I could not follow. I was driving, and actually the timing is prayer time. After that, it is very limited time, and all these things. And I was driving, so that, and I forgot. I'm sorry to our the coordinator, especially Raza Bhai. I'm sorry, I could not ask even on time today. So, since today is the subject is nuclear power plant, I was totally involved with the Taka before it was Transco nuclear power plant. It is called Baraka. 4 units are there, as Ahmed Bhai already touched. It is around you can say 1500 megawatt each unit. We have 4 units. So I don't like to go to technical side, how it is, how the plant working, and if the question for engineers, totally it should be electrical engineers. Though conventional power plant, we have some mechanical engineer also. So in our country perspective, I as Ahmed Bhai told that around 1200 megawatt, it is also fine. 2 units are there. It is fine. So, and for your information, we have this green energy power plant, nuclear plant, as well as we have now around 3,500 megawatt from solar plant we have in Abu Dhabi. So this is going on that. Inshallah, I hope that in future I'll discuss on in details in this text. So thank you everybody, and best of luck. Thank you so much.
Thank you, Mr. Mohammed Afzal. And now I'll invite Mr. Manzoor Khan to share a few words in today's session.
Good evening, ladies and gentlemen. I'm really very honored to say a few words. In fact, I'm not an engineer. I'm a retired hotelier, and maybe few of you know me. In fact, I was just very, with the interest, I was just listening our speaker, Ragib Nihal Sadab's, what is called today's presentation, nuclear energy, importance, sustainability, and smart technology. In fact, I was just trying to understand the subject in details. Of course, I don't have that that idea in details, but I was just observing our young stars
how he was presenting with full confidence, and I was just trying to observe it, and it is really remarkable. In my perspective, I told earlier also we want to see our new generation should come out, and they have been very specifically the ways he was been presenting. His presentation was excellent. Of course, I'm not in that field, but I understood so confidently he was just talking. Ragib, congratulations, and we wish that we can listen to your in future what is called other presentation and updates. And congratulations again. I want to say thank you very much, and I must appreciate our moderator. Unbelievable is the way she was talking. It is also another milestone for our community. Numaira Iram, beautifully. Congratulations. Keep up your good work. And I don't want to say more words, but I'm really very happy and waiting to hear you from all of you guys in forthcoming days. Thank you very much indeed.
Thank you, Mr. Manzoor Khan, for your kind words. Now I will invite our chief guest, Dr. Habibul Khondker, to share his insights on today's session.
Thank you, Numaira, for giving me the platform. Actually, there should not be any chief guest. There should be maybe a rapporteur or someone who just comes at the end and says few things about the proceedings. I think that would be ideal. So I see myself in that role, not as chief guest. We should do away with chief guest concept completely. Now, as a rapporteur, as someone who followed the discussion very closely, I have a few comments. First of all, I want to congratulate Ragib Sadab for an excellent presentation. And yet, in all presentations, we have some gaps. Now, I'll not start with the gap. I'll start with my personal kind of relationship with nuclear energy. I'm a sociologist, but while I was a graduate student, I did visit a nuclear power plant in America, and that nuclear power plant is in Connecticut. Now, I was a student in Pittsburgh, Pennsylvania, and 3 Mile Island is located in Pennsylvania. I remember driving past 3 Mile Island. It's in Harrisburg, which is the capital city of Pennsylvania. And then there was a movie, and everyone watching and following this conversation should watch that movie. It's called China Syndrome. Remarkably, the movie came out before the accident. So it's the reality imitating art kind of situation. After the movie came out, then the accident happened. And the movie is exactly about a nuclear accident, very much like what happened in 3 Mile Island. Now, because of that, and subsequently in 1986, there was Chernobyl. And Chernobyl impacted Europe. Germany was impacted. It's not that out of fear they went against nuclear power plants. I mean, they had nuclear power plants and so on, but they kind of pulled back because of the consequence, and that consequence generated a public reaction. Now, one thing we have to really take into account, that you start a technology for good things, for good reasons. And I think Ragib pointed out very, very eloquently, very, very analytically, all the good points that come with nuclear technology. Absolutely no question about it. I would recommend Ragib to follow up on Bangladesh, because Bangladesh has already initiated. Rupur plant, they have 2 units. One unit is 90% completed now. The other one is 70%. So Bangladesh is actually entering nuclear power age in months, in years, actually in months, I think. The first reactor would be generating electricity. It's really within 2026, and they're on a schedule. And they actually invested $11 billion. The money came from Russia. So we really need to follow up, and we need to update ourselves on what's going on. Apart from that, what was missing, a minor point is missing, and I'm sure Ragib will pick it up. that there's a huge deal in the area of nuclear medicine. You see, this is one of the bones of contention between countries, involved in war right now. That they're saying, look, we need nuclear technology for medical purposes. So in every hospital around the world, in advanced countries, you have nuclear medicine. And that's an absolute necessity. Now, I remember attending a seminar many, many years ago, 4 decades ago, when I visited the Connecticut nuclear power plant. And in that conversation, the idea of fusion came up. And the main difference between fission and fusion, Ragib pointed out very clearly, but the other difference is that in fission technology, you leave dangerous nuclear waste. In fusion technology, there is no nuclear waste. And that's why China is moving ahead, and they're actually doing very good work, as far as I can tell, with regard to fusion technology. And that would be the future. But what struck me, one very interesting point made by one of the commentators, that a nuclear technology, nuclear power plant generates jobs for engineers of all fields, electrical engineers, civil engineers, and so on. So in terms of job generation, this is a very important technology, a very important power generating strategy. Now, you outlined all the positive points, and I really appreciate that. But in any debate, when you have a discussion of nuclear power technology, and recently I was in Germany, and I was in other places in Europe, especially in France, and you're absolutely right. In France, they're ahead. Slovakia is ahead, and you mentioned Korea and so on. But we also have to be very careful, because you remember in the Russia-Ukraine war, the former nuclear reactor, they're out of service now in Ukraine, has been targeted. And why it is dangerous? Because they still are storing nuclear waste materials there. Now, if there's a major strike, major missile attack, that might release nuclear radioactivity and endanger lives of tens of thousands of people around that plant, So there are risks. We live in a very uncertain world. So we really have to deal with some bigger question, that we can pursue nuclear technology, but we really have to be careful that it does not get into the wrong hands, and it does not fall into this kind of war situation where it can be targeted and so on. And this was the concerns of people like Einstein, people like, the leader of Manhattan Project, and the movie, the Manhattan Project movie, I think is extremely important. So one can see the politics of energy and so on. Now, one of the questions that came up in this discussion is why only 9% of the world electricity is being generated by nuclear power and not more. It's simply because of those concerns that many countries have. But apart from those concerns, the other point that we also have to take into account is that there's a great deal of politics involved. People who have invested billions of dollars, maybe trillions of dollars in oil and gas and all the, non-renewable sectors, they're not going to lose money. They're not going to allow renewable and nuclear technology to come and put them in a huge challenge. So the politics of power, politics of energy is a huge thing. And in our university, we have a specialist in international relations areas. We have colleagues who teach that subject, politics of energy. So we really need to expand the discussion a bit more, but we also have to be extremely cautious that some people are technophobes, they're always worried about technology, and some people are always with technology. We really have to look at both points of view, that some technologies in theory are great. We can get so much out of that technology, but you also have to be cautious about, some of the dangers that we have encountered over the last 50 years, since the war, the war happened like 1945, August 6, August 9, these are dates that we remember. And no one thought about that this could be unleash so much damage, in a very short period of time. So those are some of the warning signals we have to keep in mind. But at the same time, science cannot simply stop. Technological growth cannot stop. But we have to walk on these roads very, very cautiously. But again, I don't want to speak too much today, maybe for another time. But I want to congratulate Ragib and Numaira for conducting this session with poise, with professionalism, with great skill and confidence. But I would also like to thank Mr. Rizal Rahman, who is the leading light for all this, that he has done a great job, an excellent job in creating this space for discussion and deliberation. So I congratulate Mr. Rizal Rahman, and I thank you all for giving me this opportunity to share my thoughts. Thank you very much.
Thank you, Mr. Habib Khondker. With that, we conclude today's session. Thank you all for joining us, and we look forward to seeing you at our next webinar. Have a wonderful evening.